Okay. There are two more important topics. One is this operator part, which partially I have given you an idea. There's a different way of notating these operators also, about which I will tell, and go to the most important concept called the Bloch sphere or Bloch sphere concept of quantum computing. Okay. The operators, as I have said, Pauli operators, I think Pauli, it's not Pauli, it's Pauli. Pauli's X, Y, Z operators are there, about which we had discussion in the previous videos. Okay. Along with this, there is an extra one, the identity operator. This also I made a mention in the previous video. Okay. Yeah. There is a different notation for this. Sigma naught stands for the identity operator, that is 1001. Sigma 1 stands for the X operator, that is 0110. Okay, sigma 1 you can say, or sigma X also you can say. Okay, yeah. Sigma Y, and of course this is also called sigma 2. Sigma 3 is no change in state, only change in phase. So 0, -1. Okay, also called sigma Y or the Z operator. Okay, right. Now we will see how these operators are operated on the qubits or the basic states. The basic states, basis also you can say. Basis states are ket 0 and ket 1. Basis states of qubit. Of course, if superposition principle is there, then I'll go with ket xi, which is a combination of ket 0 and ket 1. That means what? Any particle, any photon can exist in superposition principle. That's what the quantum mechanics concept says and starts with. Okay. Okay. How does this operator operate on ket 0? How does this operator operate on ket 1? Is what we will see. Of course, this is the identity operator. So by the name itself, identity operator means what? Whatever you given, same thing comes out. Of course, you can check ket 0 only comes out. Similarly, sigma naught on ket 1 gives you ket 1 only. Okay. Coming to the remaining ones. How the operators are operated on the basic states. Okay. So that's what I'm. Sigma 1 is what? 0, 1, 1, 0 operated on 1, 0. So what do I get? 0, 0, 1, 0. So I'll get ket 1. Okay. Why I'm doing it, don't think it's just for time pass or something. There are some conclusions that I will make. 0, 1, 1, 0 operated on ket 1 would give me ket 0. That means what? If I'm giving ket 0, I'm getting ket 1. If I'm passing ket 0 through X gate, I'm getting ket 1. X gate, I'm getting ket 1. And then if I'm passing ket 1, I'm getting ket 0. So X gate is flips the gate, the ket or the state. Ket or state, flips the state. Okay. That's why it is like our not gate. And then usually you use U naught for the X gate. The notation, standard books use U naught for the X gate. Okay. Let's see sigma 2 when operated on ket 0. Sigma 2 when operated upon ket 1. Sigma 2 is nothing but my Y gate, 0I minus I 0. Change in state and flip in phase also. Okay. 0 and 0. I and 0. So it is I. It is nothing but I of ket 1. Okay. Similarly, 0 minus I I 0, 0, 1. This is equal to 0 minus I. So I have a minus I. 0, 0. Okay. Negative I of 0. Okay. So if you are giving ket 0, I am getting ket 1 only, but with a phase shift. Similarly, if I am giving ket 1, I am getting ket 0 with a phase shift. Okay. With Y. Yeah. Next, sigma 3. How the if ket 0 is passed, sigma 3, how with what happens when ket 1 is passed? 1 0, 0 minus 1, 1 0. 1 0, 0 minus 1, 0 1. Let's see what happens. 1 0, 0 minus 1. No, 0 0 only. So I'm getting ket 1. Fine. If I'm passing ket 0, I'm getting ket 1. 0 0. No. If I'm passing ket 0, I'm getting ket 0 only. I'm sorry. 0 minus 1. If I'm passing ket 1, I am getting minus ket 1. Okay. No change in state. No change in state. Change in phase. Okay. Yeah. This is all about how the Pauli operator operates on the basis states. Okay, now why I've discussed all this is for the understanding of the Bloch sphere or Bloch sphere. Bloch sphere or Bloch sphere. This has an important role in quantum computing. Details of it we shall discuss. Of course, first let me put like this. I'll draw the sphere to show certain things. This is my X gate towards the south pole, Y gate and Z gate. Okay. This would be my ket 1. This would be my ket 0. Of course, at the equator, I have alpha ket 0 plus beta ket 1. The superposition principle, whatever I am considering, acts at the equator part. Okay. Right. The North Pole, okay. The North Pole corresponds to ket 0. South Pole corresponds to ket 1. I'm sorry. Okay. The equator corresponds to superposition principle. Okay. What exactly is this? A Bloch sphere. It is used to for the visualization of the qubits. It is used for visualization of qubits. Okay. Yeah. Now, all this single qubit gates, whatever other X, Y, Z, T, all these are single qubit gates. These are called single. I'll talk about multi-qubit gates also. Single qubit gates. All the single qubit gates are just rotations on this Bloch sphere. Are rotations on Bloch sphere at some angle. Okay. I can say that rotation about theta is equal to phi angle gives X gate. Okay. Rotation about ket 0 to the equator. To ket 0 by root 2 gives Hadamard gate. Gives Hadamard. I have not discussed this yet. I will do it in the coming videos to go. Hadamard gate. Like that. Okay. So why I'm talking about this is there is one more representation of a qubit. See, one representation is ket xi, superposition principle, alpha ket 0 plus beta ket 1 is one way of representing, where mod alpha square plus mod beta squared is equal to 1. This condition has to be satisfied. Okay. Now, there's one more. There's one more way of writing ket. Another representation is ket xi. This is equal to cos theta by 2 ket 0 plus e power I phi sine theta by 2 ket 1. This is another notation. And now I would like to talk about this notation, because of which how all the gates act upon ket 0, ket 1, all those things I discussed. Okay. So for which what I will do is, I will just try to find out the eigenvalues for this. Eigenvalues for the Bloch sphere. Okay. Yeah. So let us see what that is. Just a second. What I will do is, first, I'm talking about sphere, right? Bloch or Bloch sphere. Bloch sphere. I'm considering, right? So I'll be using spherical coordinates. Spherical coordinates. Okay. What are the coefficients of spherical coordinates? Let's see. What that is if theta is nothing but angle 0 to pi, polar angle, phi is nothing but 0 to 2 pi, azimuthal angle. Of course, r is my radius as known. Okay. Of course, r is not there here. Now, suppose if I take the spherical coordinates, how are spherical coordinates is sine theta cos phi, sine theta sine phi, and cos theta. You can ask me, ma'am, what happened to r? I'm considering that the radius of the sphere is 1. Okay. So what happens? R is 1. That's why it's invisible. Now, n cap, the positional vector on the sphere. How does it look like when I'm taking spherical coordinates is n theta, sine theta, cos phi, sine theta, sine phi, cos theta. Okay. Now there is one representation of vectorial representation kind. Sigma x is equal to sigma bar into x cap. Of course, if you ask me what is x cap, I am considering the position vector again. It's nothing but my xi cap, yj cap, zk cap. These x, y, z are my polar now. They are in spherical polar now. Okay. So sigma x, sigma y, sigma z. Okay. So I'll go with first this thing, sigma bar, and then talk about remaining things. Okay. Sigma n is nothing but sigma bar into n cap. What is sigma bar? It is nothing but, because I'm in 3D, sigma x I cap, sigma y j cap, sigma z k cap. Okay. Right. Now, what is n cap? I know. What is sigma bar? I know. Okay. So what I will have would be ith into ith dot product I am considering. So ith into ith, jth into jth, kth into kth. Sigma n is nothing but sigma bar into n cap. Okay. I'm finding out the directional vector, right? Kind. Now, sigma x into sine theta cos phi. I dot I is 1. I dot j is 0. J dot k is also 0. So, sigma y sine theta sine phi plus sigma z cos theta. Okay. I know what are sigma x, sigma y, and sigma z, which I have discussed in the starting of the video. Okay, 0, 1, 1, 0, sine theta cos phi plus 0 I minus I 0, sine theta sine phi plus 1, 0, 0 minus 1 cos theta. Okay, just multiply them. See what happens. 0 sine theta cos phi, sine theta cos phi 0 plus 0 minus I sine theta sine phi, I sine theta sine phi 0 plus cos theta 0, 0 minus cos theta. Okay, this is my matrix. I add all the respective elements. So 0 plus cos theta would be what? Cos theta. Sin theta cos theta minus I sin theta cos theta plus 0. Sin theta cos phi minus I sin theta sin phi. 0, I don't have anything. Okay. Yeah. Next, this plus this plus this. Sin theta cos phi plus I sin theta sin phi. Okay. Then 0 plus 0 minus cos theta. Minus cos theta. Okay. I have a matrix. Resultant sigma n is a matrix. Now, if I want to find eigenvalues of sigma n. Okay, what is sigma n? Sigma n is nothing but representations on the position vector on the Bloch sphere. Okay, if I want to find the eigenvalues, what happens? Just see. Equation is sigma n minus lambda. For anything, it is like that. Is equal to 0. This is my sigma n, right? So if I take, what I'll get is cos theta minus lambda. Of course, this you see, guys. Cos phi minus I sin phi. Okay, here cos phi plus I sin phi, which can be written as sin theta if taken out common, e power minus I phi. This would be what? Sin theta e power I phi minus cos theta minus lambda. Of course, this is determinant, guys. There is no closure of this bracket. Okay. It's a line. Determinant I enclosed in a line so that its resultant is a number. Right. So let's take, I have cos theta minus lambda into, if I take out minus common, cos theta plus lambda. Okay. Minus AD minus BC. AD minus BC. Okay. So sine squared is anyways visible. Sine squared theta. E power minus I theta into e power I theta. A power m into a power n. A power m plus n. And this, there is a minus sign common. A minus b into a plus b. Cos squared theta minus lambda square. A square minus b square. Okay. Yeah. There's a minus sign common for the first term. There's a minus sign common for the second term as well. Sine squared theta e power minus I phi. This is, guys, not theta. It's phi plus I phi. Okay. So it is 0. E power 0 is 1. Right. So finally, if I take off minus, what I'll be left with? Minus common in both the terms and shift it to the left. Right. Cos square minus lambda square plus a sine square is what I will have. Cos square plus sine square is 1. So 1 minus lambda squared is equal to 0 implies lambda is equal to plus or minus 1. Lambda squared is equal to 1. Hence lambda is equal to plus or minus 1. Fine. My eigenvalues are lambda is equal to minus 1 comma plus 1. Fine. Now, once I have eigenvalues, I should be finding out eigenvectors, right? Eigenvector of lambda 1 is equal to 1 is ket xi is equal to alpha beta. Let ket xi be alpha beta. Then what I will have would be sigma n into ket xi is equal to lambda 1 into ket xi. I'm not using suffixes because it's very difficult to write. If you want, I can just put a suffix, which is not a big deal. Okay. Very too complicated because already writing ket is only complicated, right? So what I have finally is cos theta, sin theta, e power minus I phi, sin theta, e power I phi, cos theta. Of course, with a minus sign. Alpha, beta, this lambda is anyways 1. So alpha, beta. Yeah. Rewrite them in equation format to get some conclusions. What I will get will be alpha cos theta plus beta sin theta e power minus I phi. This is equal to alpha. Okay. If I take alpha terms towards one side, then what happens from the first equation is, I'm in the first equation only still. Beta sine theta e power minus I phi minus alpha is equal to alpha. If I take out common, I can say 1 minus cos theta. Okay, guys? Sine theta is there. 1 minus cos theta is there. So I think I can write it like 1 minus cos theta by 2. This is equal to sine squared theta by 2. And sine theta is equal to 2 sine theta by 2 cos theta by 2. I can write like this, right? Yes. Okay. So what I will do, beta is 2 beta into sine theta by 2 cos theta by 2 e power minus I phi. So anyways is there. Alpha into this one is what? 2 sine squared theta by 2. Because there's a minus sign, it is sine squared. Otherwise, it would have been cos squared. Okay. So 2 and 2 goes off, sine and sine goes off. So I'll be left with beta cos theta by 2 e power minus I phi. This is equal to alpha sine theta by 2. Okay. Now, how can some two different bhayanak quantities be equal to one another? Okay. And then I can clearly see on the right hand side again, on the left hand side again, there is this I part. I part means the left hand side is an imaginary number. Right hand side is looking like an real number. Okay. Now, this can be possible. Just see here. This can be possible. Above equality can be possible only if alpha is equal to e power minus I phi cos theta by 2 and beta is equal to sine theta by 2. Or either ways I can write, instead if I want to remove this minus sign, I erase this off. Okay. So this shifts here. So minus sign turns into positive. E power I phi. Okay. I just want you to have a look at the notation of the generalized notation. Okay. About which I was mentioning. Cos theta by 2 ket 0 plus e power I phi sin theta by 2 ket 1. What are those values? Alpha. Alpha is cos theta by 2. Beta is e power I phi sin theta by 2. If I write ket xi to be alpha ket 0 plus beta ket 1, is it not the same notation that I have used above? That's how I get that notation. Okay. Yeah. Next, for I have one more eigenvalue as lambda is equal to -1. Let ket xi be the eigenvector. Okay. I'm telling, I'm not using the suffix notation. If needed, please use it. Not a problem at all. Okay. Sigma n ket xi2. This is equal to -1. Na? So ket xi2. Write the same thing again. Write back the same matrix again. Sin theta e power minus I phi. Sin theta e power I phi minus cos theta into alpha beta, this is equal to minus alpha minus beta. Okay. Alpha cos theta plus beta sine theta e power minus I phi. This is equal to minus alpha. Alpha sine theta e power I phi minus beta cos theta is equal to minus beta. Okay. Now, if I solve the first equation, of course, here I've just skipped the second equation. But then solving one has given me both the values. I can substitute and recheck whether they are satisfying or not. Any one equation we can take and finally get. Okay. Yeah, coming to the second equation. No, coming to the first or second, anything is fine. Alpha cos theta plus alpha. This is equal to minus beta sine theta e power minus I phi. Okay. Now, alpha into 1 plus cos theta. The same technique which I used in the for finding the previous eigenvalues, eigenvectors, I'm sorry. Alpha 2 cos squared theta by 2. This is equal to minus beta 2 sine theta by 2 cos theta by 2 e power minus I phi. Okay. So 2 goes off, cos goes off, 2 goes off. Okay. Alpha cos theta by 2. This is equal to minus beta sine theta by 2 e power minus I phi. Okay. Of course, to remove the negative value, I can take this side e power I phi. Okay. So beta should be e power I phi cos theta by 2. And alpha should be minus sine theta by 2 for this above equation to be valid. Okay. That's how I'll get the values of alpha and beta when lambda is equal to minus 1. Okay. Ket 0 plus e power I phi cos theta by 2 ket 1. This is how I will find out. Of course, alpha by beta if I write also from here. Just see alpha by beta if I write, I know clearly what's my numerator and what's my denominator from which I derive. Okay. Therefore, to represent anything on the Bloch sphere, I'll be needing this notations. Why do I need Bloch sphere? As said earlier, to get any gate on the Bloch sphere, it is just a rotation about an axis. Gives me all the gates or the operators. Okay. Now, any qubit, when it is tossed, time evaluation of it can be got only through this Bloch sphere representation. Okay. Quantum system dynamics can be betterly understood using this Bloch sphere. Okay. With this, I will just stop this video.